Hi guys, today is May 28th and we are starting our last chapter of the school year, chapter 4, and it has a lot of algebra. It's basically all algebra, so you guys are going to get a feel for what's coming to you next year. So let's get started. Today's lesson is on powers and exponents. And ladies and gentlemen, exponents basically is a type of math operation, but what kind of math operation? It is repeated multiplication, ladies and gentlemen. Basically, it's a number, right, multiplied by itself certain amount of times. Now, this 3 to the second written as with exponential notation, big 3, small little 2, 3 is called a base. Okay, and 2, we call 2 as an exponent. Okay, and ladies and gentlemen, the exponent is the rule maker. It tells how many times the base is going to be multiplied by itself. So 3 to the second simply means 3 times 3, or 9. Okay, so again, 3 to the second power, or 3 squared, or 3 raised to the second power, right? There's all these ways we can say that. Again, the base gets multiplied repeatedly, and exponent tells how many times that's going to happen. So the first set of examples is dealing with writing your expressions using exponents. So remember, we need a base, and then we need to figure out what the exponent is. So I see the number that is multiplied by itself 3 times, and that is -1. So my base is -1, and I see it multiplied repeatedly 3 times. So it's -1 to the third power. Example number 2, k plus 2, I see it's repeatedly multiplied. So k plus 2 is my base, and I see it multiplied by itself 4 times. Okay, moving on to the next example. I'm asking you to rewrite this expression using exponential notation or exponents. So 7 has no one to be multiplied with, so I'm just going to write 7. But if you had another number, you could have multiplied them together. A I see 3 times, so it's going to be a to the third. B I see once, and C I see 2 times, so C squared. Okay, ladies and gentlemen, I'm going to skip example B and I'm going to come back to it. In the meantime, I'm going to ask you to take a look at this. Look at this, ladies and gentlemen. Simplify using PEMDAS. And I said be careful. And you do need to be careful because this is where silly mistakes happen. So there is a difference between -3 to the second and parenthesis -3 to the second power. Now, let's take a look at -3 to the second without parentheses. Now, in this case, negative simply means the opposite. Okay, so I'm asking you, what is the opposite of 3 to the second? I'm going to rewrite it. What is the opposite of 3 to the second power? Now, I know 3 to the second power is 9, right? So the opposite of 9 is -9. Do you see that? We can also write it like this. Negative is not just by itself. It has 1 attached to it. So we can say -1 times 3 to the second. 3 to the second is 9, so -1 times 9 is -9. Okay? Okay. Now, what is -3 with inside of the parentheses raised to the second power? Well, my base is -3 times -3. Okay, -3 times -3 is +9. So now notice that whenever we have the negative base raised to a certain power, right, we have to multiply. That base is negative, so you have to multiply it by itself as many times as it tells you. Sorry about my dog drinking water in the background. He just came back from the walk. Okay. So example number 4, -7 to the third power. Notice there's no parentheses, so I'm simply asking you, what is the opposite of 7 to the third power? So -7 to the third, right, is going to be negative, and 7 to the third is 343. So it will be negative 343. Okay. Let's take a look at example B that I skipped. So negative 5 to the second. Notice there's no parentheses, so I'm just going to rewrite it like this. It's going to be negative, right, 5 to the second, or negative 25. So my answer will be negative 25, right? And now I'm just simply writing down the variables. B I see once, C I see once, and D I see 3 times, so that would be D to the third power. Okay, moving on to evaluating. We're going to substitute the values given and simplify our expression. A plus B to the third power. So let's plug it in. A is 5 plus B. B is negative 2. Remember what I said before. We need to, every time you're substituting a negative number into your expression, you need to put it inside of the parentheses. Negative 2, and everything is to the third power. 5 plus negative 2 will be positive 3, and 3 to the third power will be 3 times 3 times 3, right? Which is 27. 27 would be your final answer. Moving to example B on the other side. 2 minus C squared, 2 minus, and C is 3/4, so 3/4 squared. And notice 3/4 squared is simply 3/4 times itself twice, right? 3/4 times 3/4. So that would be 2 minus 9 over 16. I'm going to borrow, remember borrowing? So I'm going to borrow 1, so this became 1, right? And it will be 1 and 16 over 16 because I'm looking at this denominator right here. Minus 9/16, and my answer is 1 and 7/16. Okay, the next set of examples, please pause me and solve these on your own, and then let's compare the answers. So I'm just quickly going to do that. 5 squared plus y, which is negative 3 to the third minus 2. 5 squared is 25. Negative 3 is inside of the parentheses. Negative 3 times negative 3 is positive 9. Positive 9 times negative 3 is negative 27. Minus 2. 25 plus negative 27 is going to be negative 2 minus 2. And remember to do keep, change, which will give you negative 4. Okay, moving on to the next one. 10 times negative 7 squared minus 1 to the 5th power. Negative 7 inside of the parentheses times negative 7 would be positive 49. So, and minus 1 to the 5th is simply 1. 490 minus 1 equals to 489. And that is your final answer. Finally, moving on to the last set of questions, I'm asking you to compare the two. So really quickly, negative 6 to the 4th is the same as negative 6 times itself 4 times. Negative 6 times negative 6 is positive 36. The same thing on this side, and that's going to be positive 1296. 6 to the 4th is 6 times itself 4 times, which is exactly the same thing. So your answer should be equal sign. They are the same. Now finally, last part, negative 4 to the 6th power. And this, I'm not going to, expand this. I'm just going to tell you the rule. So the rule is whenever we have a dealing with negative base. So negative base, okay? Whenever we have even, our negative base has even exponent, that should give you a positive answer. An odd exponent should equal to negative answer. Okay, so 6 is going to be even, right? It is even, so you will have a positive answer, and 7 is odd, so it's going to be negative. And honestly, you don't even have to do the computation because negative is always smaller than positive, so your answer will be negative 4 to the 6th power is greater than negative 4 to the 7th. So I'm hoping that this lesson was not too bad compared to our last chapter. Let me know if you have any questions, and I will see you in the next lesson.